Okay, so this is a more complicated question. This is a question about a car loan. We're trying to figure out the difference between two incentives we've been given in trying to buy a car. We're trying to buy a car for $56,000. It's going to be a nice car. And we have $11,000 saved for down payment. And the dealer's giving us a choice between two different options, and we have to figure out which option is the best option for us. The dealer will take $3,000 off the price of the car, and then you'll have to pay the rest back within 5 years at 5.6% interest. For the second incentive, there is no cash rebate, no money saved off the price of the car, but free financing, no interest for 5 years. So if you pay back the price of the loan within the 5 years, you don't actually pay any interest. And so what we're really being asked is, do you think that a loan over those 5 years at 5.86% interest, do you think that the interest on that loan is going to be more or less than the $3,000 that they're offering you off the car? We have to do that calculation. We can't know that without actually doing the calculation. But as mathematicians, as people applying math to the real world, we have to think about problems before we just jump in and start putting pencil to paper. If you just kind of jump in and start writing stuff down, the odds of if you're writing right stuff down go down if you haven't thought about it first. And so that's what this kind of first section is all about. All right, well, now that we've thought about it, we've got an idea of what we want to try to do, let's grab a pen and start writing. So what I'm really trying to figure out, I sort of don't have to do a lot of calculation with Part B. What I'm trying to do is I'm trying to do the calculation of how much interest do I owe on this loan, and then figure out how that compares to my free financing option. So let's work on incentive A and figure out what is the cost of incentive A first. All right. So if I had initial price, so price initial was $56,000, and my down payment was $11,000. That means I'm not actually going to the dealer for the loan for the entire $56,000, right? So the loan amount is actually going to be $56,000 minus the $11,000 minus the down payment. And so is that going to be $45,000? Relatively straightforward math, but checking yourself is always a good idea. 56,000 minus 11,000 gives me my 45,000. Still should do it in your head first. Keep exercising that mental muscle, even if you got a calculator sitting right there. Okay. So if that's my loan amount, how do I want to solve this? Well, my rate is going to be 0.0586, right? Got to convert that percentage over to a decimal. And using incentive A, so for Part A, the incentive is $3,000 off the price of the car. And so that $45,000 actually becomes, so that implies that my principal is going to be that $45,000 minus the $3,000 incentive. And so this principal that I'll use in that formula is actually going to be $42,000. All right, monthly payments tells me that N equals 12, right? And so N equals 12. And then T is going to be 5 for 5 years, right? Okay. Those are all the numbers I need to do this calculation. And so I'm going to find out that my payment, PMT, equals my $42,000 loan times my rate, 0.0586, over my 12, divided by 1 minus 1 plus my rate, divided by 12, raised to the negative 12 times 5. All right, and then that's all in my denominator, so we put that all in brackets, but that's really just to show that it's all in my denominator and to help me out when I type it into my calculator, because if I don't put parentheses around the whole thing won't be in the denominator of my calculation. Remember, calculator's a little bit tricky when we type stuff in. I realize that this calculator app does support that pretty print, and a lot of modern calculators do support pretty print where you can type things into something that looks like a fraction. I'm going to type it in the old way because a lot of older calculators don't support that, and I want us to see how to type this in correctly on older calculators. So I have that 42,000 times, in parentheses, 0.0586 divided by 12. Believe it or not, we actually don't need those parentheses. But now that we're getting into a denominator that has multiple pieces, multiple terms to it, and multiple factors, I have to put an open parenthesis to make sure that everything within those parentheses is in the denominator. And that really just corresponds to this pair of parentheses. So now I'm going to type in my 1 minus, and then I'm going to open this set of parentheses. So I'm really just kind of creating what I have written down over here. It's part of why I wrote it the way I did. 1 plus 0.0586, then divide that by 12. And then I'm going to use my right arrow because this app is already putting the closed parentheses in for me. And so I want to be in between those two parentheses to put this exponent in. And so now with that exponent, I'm going to use my up arrow. And in an older calculator, I would need to put this within parentheses. So you don't need to do that in a newer calculator, but in an older calculator, you would need to, because it would just show me that up caret. It wouldn't actually show it go up into the exponent like this. So I'll have negative 12 times 5 in that exponent, and then I'm done typing that in. So I hit enter, and I get $809 is my payment. So I'm going to clean up those things that I wrote down. And I'm going to say that, so under incentive A, my payment is $809.25. Couple of different ways to think about this. The way my mind wants to organize this is I want to find out at the end of my 5 years, have I paid in more than the $45,000 that my loan amount would be with zero interest? Because that's my incentive B is $45,000. That's what you pay over 5 years, total over 5 years. So the question is, at $809.25 a month, am I actually paying more than that? That's kind of my question for myself. Is incentive A costing me more money than incentive B? Well, how do I find out how much I paid in over 5 years every month? Well, I take the amount I pay in every month, I multiply it by 12, because there's 12 months in a year, and then I multiply it by 5 years. And so I'm going to take that 809.25, multiply it by my 12 months in a year, multiply it by my 5 years, and what's that going to give me? So hopefully this will do the answer. Yes, answer. And then that's times 12, and then that's times 5. And I hit enter, and it's going to say that I'm actually paying $48,554.78. And so this is actually paid in the A option. Well, actually paid in the B option not paying, actually paid. I realize car loans can be painful. Actually paid in the B option is just the loan amount. Because there's no interest on the loan, right? And so the original loan amount was that $45,000. So of $45,000. And if I compare that value to that value, I see that B is actually the cheaper option, right? Even though they took $3,000 off the top, they knew they were going to get what? Basically $6,000 worth of interest out of you, $6,554 worth of interest out of you. And so they knew they could give you half the interest back, so to entice you to take that version, because in the long run you were actually going to end up paying them more money. They're playing the long game on you. And part of studying this kind of math is so that you can make informed decisions. Can't really tell you that one is necessarily better than the other as far as the payments go and how that fits into your budget. But what we can do is we can tell you that you save money in the long run by going with option B. And so if you can make that work with your lifestyle, it's probably a good choice. All right. Hope that helps us with our calculations.